Good morning, explorers. Welcome to Virtual MOSI. My name is Charlie. I'm one of the amateur astronomers here at MOSI. And today we have a great Virtual MOSI for you. In fact, we have a question to answer, and the question is, what can be found at the center of our universe? Well, we're going to try and answer that question as we go through it, but you got to understand this. This is a big topic. Things that people study for years and such, we're going to try and condense into less than 15 minutes. So good luck with that. The other thing you need to also understand is, this is a tough topic to understand. Albert Einstein came up with a lot of the stuff that we think about the universe today, but he himself felt like a lot of it was just crazy and hard to understand. So if you have more questions than you have answers at the end of our show today, I want you to be trying to find answers to those questions. Continue your research. My idea here is to spark an interest. So let's talk about the universe. First of all, let's talk about astronomy and how our understanding of the universe has increased over time. Because as time goes by, we get better instruments, we get better ways of using them, and our understanding has changed a whole lot. Let's go way back before the 1600s. Back then, people understood that we had an Earth-sized universe. Basically, what our understanding was there was the Earth that we lived on, and then all the pretty lights at night and the sun by day were just in this big old dome around the Earth, maybe a few hundred miles above the surface of the Earth. And that was it. But we had only our eyes to work with. There were no telescopes or anything like that. So our understanding only was as far as our own eyes could see. Then came Galileo. Now, Galileo in 1610 became the first person to use a very primitive telescope to observe the sky and record his observations. That telescope enabled him to see that the Earth was not at the center of the universe. In fact, the sun was the center. And from Galileo's studies and understanding about how everything orbited and such, we basically came to understand that we were part of a solar system with us and a handful of other planets, basically making up everything. All those stars and such were just in a little dome just outside the solar system. So we had a solar system-sized universe because that's all our telescopes could really see. As telescopes got better, by the turn of the century, and here I mean 1900, not 2000, we had better telescopes, and we realized that we started to understand that our universe was bigger. All those stars we saw were a part of an organization that we came to call a galaxy. At that time, all we understood was there was a big old disk, and everything we thought was included in that big old disk in the sky. Let me show you a picture that you can kind of get an idea about what the telescopes were showing us back then. I want you to zoom in very tight on this picture here. Now, this is a modern picture. It's got lots of colors, okay, probably Hubble Space Telescope. But let's imagine you're looking at this through a really primitive telescope. You'll notice that there are little smudges here, okay? People saw these smudges in their telescopes, and they didn't understand that those were galaxies. They just thought they were weird-shaped clouds of gas in our own galaxy. All right, you can come back out now. And so that's the way people were thinking for a long time. Then along came a fellow named Edwin Hubble. Now you know this name because the Hubble Space Telescope is named after him. Now Edwin Hubble came to really be a power in astronomy right about the year 1919. And that's when the 100-inch Hooker telescope saw first light. This was the biggest, baddest telescope that had ever been developed at the time. With this telescope, what Hubble was able to tell was that those weird little smudges that you saw in the picture here actually had separate stars in them. It was the first time they were able to see individual stars in another galaxy because the instrument was that good. When you were able to pick out individual stars, he was able to figure out some stars were certain variables called Cepheid variable stars. With that, he came to the realization that these galaxies could not be a part of our Milky Way galaxy. These smudges were in fact galaxies that were super far away from our galaxy. He also began to understand, as he studied these little smudges, that the further away one of the smudges was, the faster it was moving away from us. So what he saw was basically that nearly every galaxy in the entire universe was moving away from us, and the further away that galaxy was, the faster it was moving away from us. That's Hubble's law. So that was one of his great contributions to science. So with Hubble, we began to see a universe that was much bigger than our own galaxy. We now know the universe contains some 150 billion galaxies, each of them with billions of stars. So it's a very big universe out there. But trying to understand the expansion of the universe is very difficult. Hard for me to explain to an audience where the kids can be all kinds of ages. And that's why we use models. I have a model over here. Now, the tools I'm going to be using today, including the picture I've already shown you and this model right here, are all from a source that we call MOSI in a box. This is something that we created to help teachers show really difficult concepts to their students, okay? And MOSI in a box is something that you can rent from MOSI and take some really cutting edge materials for the classroom. So here's a model that I have showing the expanding universe. And you can kind of get an above view of this. What we want to notice is this. I've got a bunch of elastic bands here, okay? I have these circles that are all numbered, and I have these galaxies that are pinned to the elastic bands. I have a series of galaxies that are pinned at the 3 level, okay? And a series of galaxies that are pinned at the 6 level. So as the universe expands, what the elastic bands are representing is space itself, okay? So when I pull on a rope down here, we're going to stretch these elastic bands, and notice how the galaxies move in response to that. So here we go. Space is beginning to stretch. Now, what do you notice about it? Well, first of all, everything is stretched away from everything else. These are further away from each other than they used to be. These are further away than they used to be. Even these are too. But notice this too. The inside ones started at 3, and they've all moved to either 4 or 5. Okay, so the inside galaxies only moved 1 or 2 spots away from where they were at the beginning. The outside galaxies started at 6, and they're mostly now at either 9 or 10. So the outside galaxies have actually moved 3 or 4 spaces. The inside galaxies have only moved 1 or 2 spaces. What this is trying to show you is exactly what Hubble saw when he saw that the distant galaxies were all moving faster, and they are in this model too. So that's why the outside galaxies move further away than the inside galaxies, because the amount of space between them has actually, there's more space to expand. So that's an interesting model, but a lot of folks have a hard time understanding things from a single model. Sometimes we have to have other models that maybe connect with you and you understand differently. If you like baking bread, try this one. This is a model called the Raisin bread model. And what it shows is we start, of course, with a lump of dough. The raisins are inside. As we bake the dough, the bread gets bigger and bigger. It rises, okay? And so you end up with a piece of baked bread like this that's much bigger than the dough. The raisins haven't changed their shape or size, but they are all spread out to each other because the space in between them has actually expanded as the bread expands. Now, if you're still a little confused, just understand that basically in our model, everything is moving away from each other, and that's what our observations are showing us as we study the universe and the stars with ever increasingly better tools. You know, we now have the Hubble Space Telescope. We have more space telescopes on the way. Our understanding increases as our tools get better. Now, here's one thing too I'm going to throw out there, and I can't answer the question because it's a bigger question than we can even touch on, and we're not really got any data about it. But one of the things that we are understanding from our observations is the rate at which space is expanding is increasing. As time goes by, everything is expanding further and further away from each other, faster and faster. So that's pretty crazy, but how do you explain the fact that things are increasing in speed as they move away from each other? Well, that's where a weird concept called dark energy comes in. Now, dark energy is something scientists know nothing about, because all they know is that the rate of expansion of the space is increasing as time goes by. They don't really understand why, so they came up with something called dark energy. Maybe someday we'll actually be able to figure out what that is, but for right now, dark energy is just a way to describe something we don't understand. And if that's uncomfortable for you, astronomy is not the place for you, because we don't understand a lot more than what we really understand about space. The universe is a huge place, and understanding it is going to take time. And time is something that is very valuable and goes by quickly. So I don't doubt that if I did this program like 10 years from now, I might have a lot different information for you, because we'll have had those additional 10 years of study and observation. So what you really need to think about is this. The universe is expanding. The space itself is expanding. It's not even that the galaxies are necessarily moving away from each other that fast because of motion. It's that space itself is expanding. Now, that's a terribly difficult concept. This is Einstein level stuff, okay? So I don't expect you to really understand it, but just that's kind of what the baking of the bread and the elastic is trying to show you, is that space itself is just getting bigger. So if everything started as one little central point of energy that exploded into the universe in the Big Bang concept, and that is the leading concept still among astronomers, is that in the first few minutes of the universe, there was a huge expansion from basically nothing but a ball of energy into matter as we know it today, expanding ever outward. If that's the case, then you would think there ought to be a center of the universe, okay? And if so, what's at the center? Well, the problem is, the question I asked is a trick question. When I said, what's at the center of the universe? Well, we're limited by our point of view. Let me show you what I mean. So I have a picture here. You can think of each of these dots on this picture as a separate galaxy, okay? So we're going to focus on galaxy number 2, right here, smack dab in the middle. Now, as space expands between all of these dots, watch what happens. I've got an overlay that shows this area just a little while after. Now, when I say a little while, I mean billions of years after, but watch. All right, so dot number 2 is overlaid, so I've got dot number 2 in the middle. But notice what's happened all around it. Everywhere, every galaxy appears to have moved away from dot number 2. That's why you have all these double images. There's galaxy 1 originally, there's galaxy 1 afterwards, there's galaxy 3 original, there's galaxy 3 afterwards. Every single dot has a mirror that appears to have moved outward. You would think galaxy number 2 is at the center of the universe. But that's only because we're looking out from galaxy number 2. Let's imagine a race of aliens who live on galaxy number 3, okay? Same overlay, but we line up everything on 3. Notice what's happened here. Every single galaxy, 2 has moved away from 3, 1 has moved away from 3. Every galaxy in the entire universe appears to be moving away from galaxy 3. Is 3 at the center of the universe? No. It just looks that way because the universe itself is expanding. Galaxy number 1, same thing. Everything moving away. Is 1 the center? No. And so when I say that I've asked a trick question, basically what's your takeaway from this is we don't know of any center of the universe, okay? Everything is moving away from everything else. We can only see the universe from where we are here on planet Earth. We can't travel to another galaxy and look at it from there. We can't even get out of our own solar system. So this is pretty big next level stuff. Scientists can't even agree on what the shape of the universe is. Is it a sphere expanding outward? No, most scientists believe not. They come up with all kinds of crazy shapes that look like origami that somebody has done. And again, this is us trying to match theory to our observations with the tools we have at the time. Now that understanding is going to change as things go by, but basically there's no center of the universe that we can see or understand or look at to say what's at the center of it. The universe itself is always and will be always ever changing. Woof! Okay, that's some crazy stuff, Charlie. I know. So many questions. I wish I could answer them all. I wish I understood it all. But that's the beauty of science. That's the beauty of astronomy especially. There's always mysteries. There's always things you can explore more. And I hope that some of the talk that we've had today inspires your imagination to go look and explore some more. I want you to keep discovering out there and join us again on another Virtual MOSI. So long for now.